Hello everyone, this is Mithushi. Welcome to the enhanced AI-powered loan approval system provided by Pregrad. This is a Streamlit web app that predicts a customer's loan default risk and explains the decision with interactive visuals. The goal is fast, that is, interpretable credit risk screening. Users fill a small form. The app scores default probability with logistic regression, categorizes the risk into 5 levels, and provides a clear approve or reject suggestion with confidence. Here you can see I've opened readme.md file. Now, key features include a 3D style risk gauge, feature impact bars, and a confidence meter. The model reports 78.8% accuracy on a 41,188 record dataset, with the decision threshold at 60% to balance approvals and risk. Now, I'll show you all the files that we have made so far. This is the loan approval system. Now, the readme.md file is for public facing summary, for features, visuals, and basically how to run. The enhanced loan approval system is for the basically entire app logic, model weights, prediction math, explainability charts, and the UI. The run app bat is a simple launcher that prints instructions and starts Streamlit. The requirements.txt proves reproducibility, explains all the libraries that are needed for our application. Mhm. Now let's open the terminal. Now we'll first check which Python version is installed by the command python version. As you can see, Python 3.13.2 is installed. Now we'll check if all the required libraries are installed or not. .txt. As you can see, the requirements are already satisfied and installed. Now for running the application, we'll do Streamlit run enhanced loan, name of a file, .py for Python. Now this will be running in a browser, as in here Microsoft Edge, and it will be as run as a local host. So we'll get to it at the end. For now, let's see our main program. The app uses Streamlit for UI and pandas for data handling and plot.ly for visualizations. These are basically all the libraries we need. And the page configuration sets the title, icon, and wide layout so the charts fit well. Now for the model parameters, this is all the CSS I've done. I've tried to make it look colorful and appealing, visually appealing. Now for the model parameters, coefficients, intercept, and optimal threshold. This project uses a logistic regression scoring approach. The coefficients, these, the coefficients dictionary holds the learned weights for each feature. The intercept is the model bias, and the optimal threshold is set to 0.6, meaning probabilities above 60% are treated as predicted default. Now, choosing 0.6 rather than 0.5 basically reduces false approvals at the cost of more rejections, which is a common credit risk trade-off. For this predict loan default, now step 1 is build the linear score. For each feature, we multiply the user's encoded value by its coefficient and add it to the intercept. This creates the raw log odds score. Now for the step 2, we'll convert the score to probability using the logistic function, as you can see here. This basically maps any real number into a 0 to 1 probability of default. Now for the step 3, threshold to decision. If probability is greater than 0.6, the model predicts default, that is, the app labels that as rejected or otherwise approved. Now for the step 4, risk labeling, the probability is mapped to 5 categories, that is very low, low, moderate, high, and very high, each with a color that matches the gauge. For step 5, explainability, while summing the score, we also store each feature's individual contribution, that is coefficient X value. The bar chart later uses these contributions to show which factors increased risk, that is positive is red or decreased risk, negative green. This makes the decision transparent. Now for the create risk gauge, feature importance chart and confidence meter. The risk gauge is a plot LY indicator. It displays default probability, colored steps, and a 60% threshold line so viewers see exactly where the decision boundary sits. The feature impact chart lists contributions per feature. Positive bars mean the feature pushed toward default, negative bars pulled away from the default. This helps user understand which inputs matter most for their case. The confidence meter shows how far the probability is from 50%. The far from the middle, the more stable the decision. This is a simple proxy for reliability. Now, as far as the main function, we have the Streamlit layout comprises a sidebar form for inputs and a main panel for results. After the user clicks Analyze, which I'll show you in just a bit, the app computes the probability, shows the risk label, renders the gauge and charts, and triggers the celebration animation for approvals. Only a subset of job categories currently has coefficients, such as management and technicians. Now, anything else is encoded as other and basically contributes to 0. This avoids pretending to model categories that don't have trained weights yet. Now, let's move on to our browser app while I just scroll down the code to you so you can pause and read. Now let's move on to our browser app. This is the application that I've made, AI powered loan approval system. Now let's just fill the sidebars and click analyze as we're supposed to do. Let's set the age to 45. Let's set this to management, technical role, yes. Marriage, university degree. Let's move the number of contacts maybe a bit. And let's keep it as it is. Contact is cellular only. Application month, let's keep it to October since October's around. And let's keep all of this like previous default, no, housing loan, no, personal loan, no. Let's click analyze and we'll see how this works. Loan is approved. So this is the low risk applicant. We fill the sidebar, we click analyze, and we observe low default probability, green risk label, and the balloons which I've added for visual appealing for approval. Now, you must question why Streamlit and Plot LY. Well, it is for rapid prototyping, interactive visuals, and an approachable UI for non-technical reviewers. And why logistic regression? Because interpretable coefficients and straightforward probability outputs, which are basically essential for credit decisions. Now, current coefficients cover a focused feature set. Expanding categories or switching to ensemble could improve accuracy. Planned upgrades include authentication, saving applications, and PDF reports. So yes, this was my application, and thank you for watching. Thank you, Pregrad, for helping me in this project. The app runs locally with Streamlit, explains every prediction, and demonstrates practical, interpretable ML for credit risk. I've tagged Pregrad, and the link is in the description. Thank you so much for watching.